previous lesson, we talked about standard deviation and how standard deviation helps us describe the way data values are clustered around the mean. So now there's two formulas for standard deviation, and the first one here, this one is used when our data is from an entire population. And there's not much difference between them, but enough to change the standard deviation slightly. And the second one here, this is when we extract data or collect data from a sample of an entire population. So we just look at a sample of the population. Okay, let's describe some of these symbols and terms that we use before we go on and talk about the equations. So this first symbol here, this one, this is a symbol that we use when we talk about standard deviation. So it just helps us to write it in shorthand that this is the standard deviation. The capital letter N, this is the number of values in our data set. This is how many values we've collected, how many data we've collected. So the number of values. XI, each of these represent each data, each value. Mu is the mean when we're talking about an entire population, and X with a bar over it is the mean when we're talking about a sample population. The two equations are exactly the same. It just helps us distinguish whether we're talking about data from an entire population or from a sample population. Now there's one more symbol here that we should talk about, and that is sigma. This is called sigma. And what sigma means is to sum all the values. So here our values are going from 1 to n, where n is the number of values we have in our data set. And we are taking each data value and subtracting the mean, squaring it, and then we're summing up all of them. And that sum is sigma. So now we take that sum and we divide it. In this case, when we're looking at an entire population here, we take that sum and divide it by n, and then we take the square root. And that is called the standard deviation, and that helps us describe the percentage of the data that is clustered around the mean. So let's take a look at an example of this. We're going to take a look at an example of a sample population here. So we've pulled 16 trees from an area, and we're looking at the number of beetles found in each tree. The data has already been sorted from lowest to highest here. So in this first tree we had 4 beetles, the second tree 5 beetles, the third tree 5 beetles, and so on. And we've drawn a histogram here, and you'll notice that this histogram looks like it's normally distributed. So let's find what our standard deviation is and other statistics. So let's start with the mean. This is a sample, so we're going to use this symbol here for that. And the mean, remember, is to sum each of these values and divide by the total number of values. So if we add 4 plus 5 plus 5 plus 6 and so on, we should get 112. And we're dividing that by 16. And that gives us 7. So our mean is 7. Now you'll notice also if we look at the middle value, there's an even number here, so these two become our middle value, and our median then would also be 7. And 7 occurs the most, and so that happens to also be our mode. So our mean, median, and mode are all 7 in this particular case. Now we want to see what the standard deviations are, and that is how many values are on either side of this mean value. And so to do that, we're going to use this formula. Because this is a sample, we have 1 over n minus 1, and we're taking the sum from 1 to n. And let's take a look at what this means. So here our n is 16, so this becomes 1 over 16, and we want to sum, 16 minus 1, 15, and we want to sum from 1 to 16 all the values in our data set minus the mean of 7 and then square them. So let's start with this part and then we'll add them. So let's begin with our first value. So we have 4 minus 7 squared, so that's negative 3 squared is 9. And we have 5 minus 7 is negative 2 squared is 4. Now we have that value twice in here. So we could write it out twice, or we could also multiply 4 by 2 when we're summing them. So let's do the next one. 6 minus 7 is negative 1 squared is just 1. I'm going to multiply this by 3 when we get to summing it. We don't need to write it out 3 times. And then we have 7 minus 7 squared is 0. Our next value is 8. 8 minus 7 squared is 1. 9 minus 7 squared is 4. And 10 minus 7 squared is 9. Okay, so now in our sum, I'm going to write this out here separately. So we're going from 1 to 16 because we have 16 values here. And what this is saying is to add up all of these values. So let's just write this out, xi minus 7 squared. So now we are summing 9 plus 4 plus 4 plus, now 1 we had 3 times here, plus 0 we have 4 times, and then again 1 we have 3 times, and 4 we have twice, and 9 we have once. So when we sum up all of these values, we get 40. And now in our formula, so now we have 1 over 16 minus 1 is 15. Now our sum here is 40. So this gives us 40 over 15. And that is 2.5. 2.667. And when we take the square root of that, we get 1.63, and then it goes on 29 and so on. I'm just going to round it to 2 decimal places. And so this is our standard deviation. And so we say that the majority of the population here, the majority of our data, is 1.63 standard deviations from the mean. So if we have a mean, we know that the average, the mean, is 7. And so we can say that 68% of our data, let me rewrite that a bit better, 68% of our data is within 1 standard deviation of that. So that means that we can take 7, subtract 1.63, 5.37 to 8.63. So within those two values there are 68% of our data. 95% are within 2 standard deviations. So that would be from 3.74 up to 10.26. So that's within 2 standard deviations either side of our mean value, our average value. And this is where the bulk of our data lies if our data is normally distributed, which in this case it is. And that's standard deviation.